Hello, 8th grade. We are going to talk about more inequalities. We will be talking about compound inequalities, which is Chapter 6, Section 3 of your notes. But before we talk about that, I want to remind you of some transformations that produce equivalent inequalities. So, to start off, we want to talk about multiplication. So, remember when you're talking about inequalities, and when we say inequalities, we're talking about greater than, less than, greater than equal to, or less than equal to. And you treat those signs like an equal sign. So what you do to one side, you always do to the other side. So if my problem was 1/2 x is greater than 2, I want to get x by itself. So 1/2 x, I need to get rid of the 1/2. I multiply by the reciprocal, which in this case is 2. So I multiply 1/2 by 2, and I multiply the other side by 2. So I get x is greater than 1/4. So again, you have to multiply by the same positive number. Now, division has pretty much those same type of rules. So if you have one that you need to divide, you divide each side by the same positive number. So I have the inequality 6x is less than or equal to 18. I need to get x by itself. I divide by 6. What I do to one side, I do to the other side. So if I divide by 6, I get x is less than or equal to 3. Some more is with our negative numbers. So we'll start with multiplication. So if I have the inequality of negative x is less than 7, again, I treat it like an equal sign. So I would multiply each side by the same negative number, and I would reverse the inequality symbol. So here I have negative x is less than 7. I will be multiplying both sides by -1, and I would reverse the symbol. So I am left with x is now greater than -7. You can see similar rules when you divide. So when you're dividing by a negative number to get the equality, you divide each side by the same negative number, and again, you reverse the inequality symbol. So my problem is -2x is greater than or equal to -16. I would like to get x by itself, so I divide both sides by -2. And then I also reverse my symbol sign. So I am left with x is now less than or equal to a +8, since you're dividing by two negatives. Now, let's go over and review some other little aspects of switching signs. So I have x is less than or equal to 3, and that is the same thing as 3 is greater than or equal to x. So when you switch the sides of the variable, you will also need to reverse or switch the inequality signs to make the statement true. What this does is this also enables you to start combining inequalities, and that's what our next lesson is going to be about. So let's talk about combining inequalities. So here's our 6.3 notes. So what does it mean when you combine inequalities? So we call them compound inequalities. And what that is a compound inequality consists of two inequalities connected by the words and or the words or. For example, if we have something to the effect of all real numbers that are greater than or equal to -2 and less than 3. How would I write this as a compound inequality? Well, first I want to pick out my keywords. First I know greater than or equal to -2 and less than 3. So I start writing it. My first one is I have x is greater than or equal to -2, and I also have x is less than 3. I would like to write these and combine them together so it is one statement. So here you can see my x is less than 3 I keep as the same as my x is less than 3. Now I have to figure out how I'm going to write this with x being my middle number or my main concern. So how is x related to both of these statements? Well, here I said x is greater than or equal to -2. Well, if I want to put it all in one, then I have to flip my signs. So I have -2 is less than or equal to x, and x is also less than 3. And what you do is when you have this done, then you are able to graph it as one statement. So when I graph it as one statement, I write my number line, and I can see here, all right, I have less, or technically this is greater than or equal to -2. So I have my -2, and I have a solid dot for that greater than or equal to, and then here I have it less than 3, so my open circle for less than 3. So if I were to figure out what number this is going to be, well, I know on my graph it has to be either -2 and less than 3. So that is one way to write these inequalities together and combine them. So now we're going to talk about how to describe certain things. So this is more of like the real life situations. So I want to write an inequality to describe this situation. So they give me the information that water is a non-liquid when the temperature is 32 degrees Fahrenheit or below, or is at least 212 degrees Fahrenheit. So you can see here my other keyword is or. It's not an and. So first I pull out my keywords. So it is 32 or below. So that means it is less than or equal to 32 degrees Fahrenheit, and then at least 212 degrees Fahrenheit. So if I write these using symbols, my temperature less than or equal to 32, or my temperature can be greater than 212. And again, this is when it's a non-liquid. So you know that it freezes at 32 degrees, so it's a solid, and then at 212, it becomes water vapor. So if I were to combine these on a number line, I, again, write my number line, and I apply what I have learned. So I know that the first part of this is it needs to be 32 degrees or less than. So that's my solid circle, and that's going less than. Then you can see these are all the temperatures in between of where it is a liquid. And then the other part where it's not a liquid is if it's at 212 degrees or greater. That's why you have your solid circles, because it's greater than or equal to. So this gives you a visual of the compound inequality that we were talking about. So the or is your space in between. So let's do another example. We have a refrigerator is designed to work on an electric line carrying from 115 volts to 120 volts. So now I have to figure out how I'm going to put this. So I know that it has to be greater than or equal to 115 volts, and it has to be less than or equal to 120 volts, because that is where it's in between. So it has to meet both of those criteria. So I go through and I say, okay, it's an and, I can put them together. So I know my voltage is less than or equal to 120 volts, but I also know that 115 volts is less than or equal to. So combining them. Now remember, if you look here, you have volt is greater than or equal to, but when I switch where my variable is, I need to switch my inequality symbols. And then if I were to go and graph this, I write my number line, and I have 115 and 120. So I know that it has to be less than 120 or equal to, solid dot, and greater than or equal to 115. So I know this is my only range of where my electric line is being carried from my refrigerator. So let's do some more. Given an equation. So here I have, now I need to solve. So this is doing multi-steps with inequalities and combining them. So So what we need to do is we need to treat each inequality sign as an equal sign. So the same rules apply. What you do to one side, you do to the other side. But in this case, you're going to have to do it twice. So I have negative 5 is less than or equal to 2x plus 3, which is less than 7. And I would like to get it so one variable is there. So what I need to do is I need to isolate the variable between the two inequality signs. So I write my original problem. Negative 5 is less than or equal to 2x plus 3, which is less than 7. And then I need to get my variable isolated or by itself. So here I can see I need to get rid of my positive 3. So I subtract 3. Now you treat your less than signs and then your less than and equals as equals. So what I do to one side, I do to the other side. So I subtract 3 on both sides of my inequalities. So then I am left with negative 8 is less than or equal to 2x, which is less than 4. Now I still need to get x isolated, so I need to divide by 2 since they are next to each other. What I do to one side, I do to both sides of my inequalities. So now I have negative 8 divided by 2 is less than or equal to 2x divided by 2, which is less than 4 divided by 2. I simplify my answer, and I get negative 4 is less than or equal to x, which is less than 2. And now I am able to graph it on a number line. So here's my number line, and you can see less than or negative 4 is greater than or equal to x, which is also less than 2. So remember your solid dots and your open dots and what those mean. And in words, the solution is all the real numbers that are less than 2 and greater than or equal to negative 4. Let's do another problem using the word or instead of the word and. So now I have 6x minus 5 is less than 7, or 8x plus 1 is greater than 25. So again, I write my original problem using the word or. And I go about it in the similar way, except for I kind of treat these as two separate equations. So again, I want to isolate x. So I have to add 5 to both sides in my first equation, and I need to subtract 1 on both sides on my second equation. So my first equation, I'm left with 6x is less than 12, or 8x is greater than 24. Isolating x, on my first equation, I divide by 6. What I do to one side, I do to the other side. Divide by 6. Second equation, I divide by 8. And again, what I do to one side, I do to the other side. So now I am left with x is less than 2, or x is greater than 3. And then I can go down and I can graph my compound inequality. So I make my number line, and I know that I have to, it's pretty much between 2 and 3, so I say x is less than 2, open circle, less than, or x is greater than 3. And in words, it is the solution is all real numbers that are less than 2 or greater than 3. Another example we have is if I have a big inequality, negative 3 is less than negative 1 minus 2x, which is less than or equal to 5. And again, I go about it the same way. I treat my inequality signs as equal signs, and what I do to my middle equation or my variable to isolate it, I have to do to both sides of my inequalities. So you start with your variable, and now I say, okay, I have to get rid of this 1, so I say plus 1. What I do one side, I do both of them, plus 1 plus 1. So now I am left with negative 2 is less than negative 2x, which is less than or equal to 6. Now I need to still isolate x, so now I'm going to do divide by negative 2. Now remember, when you divide by a negative number, you have to divide by that, and you have to reverse the inequality symbols. So if I divide by negative 2 on both sides, you can see negative 2 divided by negative 2. Don't forget, you're going to have to switch your inequality sign. And negative 2x divided by negative 2, switch your inequality sign, 6 divided by negative 2. So you will be left with 1 is greater than x, which is greater than or equal to -3. Now I have to graph it, and when I graph it, it's the same thing. I always start here. X is greater than or equal to -3. So I have -3 solid line, and it's greater than. But I also know that x is less than 1. Open circle, and then those will meet in between. So when you have your ands, you can see that they will meet in between, or there's usually a space in between. The solution is all real numbers greater than or equal to -3 and less than 1. And that, in a nutshell, is how you do compound inequalities with all of your different rules that you have learned. We'll go over more examples and do our homework in class. Good luck!